Wanted to talk a little bit about some test protocol updates that have come along in the last year. I'm Mark Escobedo, Principal Engineer at WESTPAK. And we've had what I would probably consider a year of change. Now, this year of change is kind of monumental in terms of standards, because standards don't move that fast. Changes don't occur that fast. And here we've had 3 revisions of standards that we use for transportation package testing. So right here we see it's ASTM D4332. That's the conditioning standard. We have the transit standard D4169 and the accelerated aging standard F1980. So why are we doing this? Why do we even care about these standards? And why do we even want to update the standards? Well, at the basic level, it's for patient safety. We need to keep things going, keep things moving, and we want to make sure things are safe for our families, quite honestly, our families and friends and the people that we are close to. And from a laboratory standpoint, we always are trying to bring the environment that occurs out there and bring it in to the laboratory so we can get reproducible, repeatable results that you can make good decisions about. So the first standard, we'll just jump right in, is the standard practice for conditioning containers, packages, or packaging components. And it had not a technical revision, an editorial revision. And it has to do with the atmospheric conditioning. So this standard is what helps define the temperature and humidity requirements for the purposes of subjecting the packages. The packages are subjected to this environment. It's not a simulation, it's a stimulation. And these are some typical requirements that are used in the environment or commonly used. But here's the big reveal. Here's the big change that occurred in the standard. Are you ready for it? Drum roll. There we go. The big reveal. Environmental conditioning atmospheres can be used for testing packages with high moisture sensitivity and testing with packages with limited or no moisture sensitivity. How fascinating is that? What does that even mean? So this is an attempt to bring in the consideration of moisture that we'll see later on in another standard, the accelerated aging standard. And this brings brings moisture to the forefront. Now, we've always had that. And ultimately, in the conditioning standard, you're supposed to know your environment. All of these standards say, know your environment. So if I were to take a poll right now with all of you here and say, what temperature do you need to test to? A hot condition, a cold condition, a frozen climate, hot and humid climate? Where are you going to get that information? You're going to measure it? Well, that takes a lot of time and effort. Fortunately, there's a table in the standard itself. And these are 7 common conditions that are used to define an environment, ranging from cryogenic all the way to desert. And we use these all the time. And those are the conditions that we typically see. It's going to be a frozen condition, a hot and humid condition, and typically a desert condition. Now, what about duration? How long do we leave these in? Well, the standard says 72 hours. But we really kind of understand that our product is light in weight, a lot of air, and actually reaches equilibrium in a fairly quick amount of time. So the durations are typically 24 hours at each level. So you do it 24 hours at your frozen level, 24 hours at hot and humid, and 24 hours at the desert condition. By the way, if you have any questions while we're going through this, just raise your hand. and ask it, and then I'll see if I can answer it. And then if it goes too long, maybe we can talk afterwards. Yes. Thank you. Right on cue. Okay, the environmental conditions, how does that work with elevation was the question. So the environmental conditions are assumed to be, kind of site conditions, and then we test for altitude conditions. So we can take, the altitude condition is typically done at what we call a standard condition of 23 degrees C plus 23 degrees C, or alternatively, the standard says plus 5 degrees C as well. Assuming that as you're going up, the temperature gets a little cooler. But ultimately, the environmental testing will cover anything outside of the altitude testing. So you test for each one separately. Altitude is going to be separate from the environmental conditions, and then you're testing for extremes anyway when we do the environmental conditioning. Thank you. Yes? How do I know which environmental condition to use for your product is the question. And that actually is not necessarily product specific, but what is in the environment. So again, we're testing for that really cold condition, anticipating a hot and humid condition and some sort of desert condition. If you need temperature control, that becomes a different standard. So we would take that to a different type of a standard and start talking a little bit about cold chain or condition, passive shippers, and that type of thing.
Would I have to perhaps test for 2 conditions?
Absolutely, yes. You have to test for more than one condition. When you go to regulatory, they're going to ask you about your low condition and your high condition, and something in between perhaps. So they are going to look for that, they're going to address it, and we've had people come back and have to retest because they didn't test for a cold condition, they just did room temperature or controlled temperature environments. All right, good questions. So now, I'll agree or admit that the last standard wasn't so earth-shattering, but here's one that is actually very important. And this will help you in your gap analysis, okay, for this particular standard. And it's the one we use for transit testing, D4169. So in D4169, we have distribution cycle 13. That's distribution cycle 13 and distribution cycle 12 are the ones that use the air spectrum. So those, the 13 is a single parcel going through air transport, and DC12 is for a pallet or palletized products. And the significant change in the standard was made similar to what they did for the truck. The truck standard, they took measured data. So they actually took data that they've collected of actual vehicles. And they did the same thing for airplanes. And you can see right here, we got the little box right here. That's how they measured it. They take the data, they record it, they analyze it, and then they create an envelope, because they can't capture every little wiggle, so they create an envelope over it, much like they did previously. And when they measured the airplane environment, this is what they came up with. Wow, look at that. The one on the far side over here, that's the new spectrum. This is the old spectrum. The scales are similar, and you can see that it's an order of magnitude lower than the previous spectrum. So then why were we doing this one over here? Okay, This is like sitting in an airplane and you're going through turbulence for the next 8 hours, getting shaken up. I mean, that's how intense that is. And there were 3 assurance levels. Here we have 3 levels, but they aren't considered assurance levels. And we'll see that as I explain and walk through this with you in a second. As I just mentioned, there aren't any more assurance levels. They took those away. Very much like the truck spectrum, you have low, medium, and high intensities. Same here. The red is the low, green is medium, and blue is high. You run all of these levels in a loop. So for the air spectrum, you would run it low, medium, and high for an hour. And then the second hour, you would run it low, medium, and high, for a total of 2 hours. So let's dive into the spectrum just a little bit more. So the things that really changed was the frequency band. The frequency band was reduced. Previously, it went out to 300 hertz. That's what they thought it was back many years ago. And found now that there isn't much out beyond 200 hertz. And there are higher intensities at the low frequencies and lower intensities at the higher frequencies. How fascinating is that? What does that even mean? Well, let's talk about that a little bit. Right here, this is a low frequency content. And this is where we have the biggest change. So this represents the highest amount, and it's 2 orders of magnitude lower over here. So they really found out that the low frequency content increased, and the high frequency content was greatly reduced. Look at that change right there. That drove it all the way down this region here. And then the actual frequency band that I was talking about, moving to the right, 200 hertz is the new spectrum. 300 hertz was the old one. So those are significant changes, and the changes in the low frequency content, that is really large amounts of movement. So what is going to be affected by that are things with large amounts of mass. Things that are very heavy are going to be affected more at the low frequency range than the high frequency range. For most of the medical device, disposable medical devices that we ship around, that's not going to be much of an issue. For the capital equipment, that might be an issue. But see, the other side of that is the truck spectrum actually encompasses this right here. So you're actually covered when you do the truck spectrum. You've already taken into account this content right here. And these are the breakpoints. So not that you need to memorize these. These are in the standards. And you have low, middle, low, medium, and high levels. And those are the overall GRMS from the standard. So are there any questions regarding any of this here? So this, I kind of gave you the justification for using this standard. You don't have to retest because the intensity is a lot lower than previous testing. So I know all of you have tested already to even assurance level 2 of the air spectrum. This is even lower than that. So you can write your justification for the use of this, and there isn't any gap because there isn't anything that changed significantly that would adversely affect your products. Any questions? All right, moving on. Standard guide for accelerated aging. Now, this has everybody excited. We get a lot of questions on this one, mainly because it brings humidity to the forefront. Humidity's always been there. Humidity's been in the previous revisions as well. But it said you should consider it, and that's kind of all that it left it as. Where this is like, no, we've, not only is this standard for medical devices or medical packaging, sterile barrier systems, but it's also for devices. So it's and medical devices. I had talked about that previously, where it was for medical devices. One change in the word and medical devices changes the focus of the standard. So again, just to review, it's for the accelerated aging, it's the temperature effect on products. By increasing the temperature, we can shorten the duration of time for a particular time point. For instance, 1 year. The standard suggests that the temperature should not be any higher than 60 degrees C. And the addition of humidity can make polymeric systems experience nonlinear changes. Well, what does that mean? Well, it's the changes in crystallinity can happen, formation of free radicals, and peroxide degradation can all occur from the presence of moisture. So I'm going to show you just a brief example off our website about the accelerated aging, and I talked about reducing the amount of time. So here is an example of a 24-month period, accelerated aging temperature of plus 55, ambient temperature of plus 23, aging factor of 2 gives us about 79 days. So I can get 2 years worth of data in 79 days. So now the standard says you should consider humidity. Well, how much humidity? And are we talking about the package and the product, or are we just talking about the product? And if we are going to add humidity, how much should that be? What materials are being used that might be sensitive to moisture? And most importantly is the acceptance criteria. What is it that we're going to use to identify when we have a failure? Having that in place is probably the most important. So in order to figure out how much humidity we need, we should go to a psychrometric chart. Has anybody seen one of these before? Okay, so the psychrometric chart has temperature in degrees C on the bottom. It has weight or mass of water per mass of dry air on the y-axis here. And there's a whole lot going on, right? You see these curved lines? That's the relative humidity, 10, 20, 30, 40, 50, all the way to 100%. 100% is saturation. That's where the vapor pressure in the air has gotten so great that it just falls out. And that's where we get rain, right? If we have 100% saturation, that's when rain occurs. So the standard wants you to choose some sort of humidity level. And for that, we're going to use this chart just to illustrate how much humidity or how much moisture that is. So the standard says 50 degrees C with a range, it's suggested 50 degrees C with 45 to 55% relative humidity. Well, if we look at this chart right here, 50 degrees C, and follow this line all the way up, we get to 40% right here. We don't even get to 45%, which is the minimum. So really, we're talking about adding enough moisture. This is how we add moisture into the air, by adding steam, getting moisture into the air. It's off the chart. So are we going to use plus 50 C and 45% relative humidity? 50, 55%? And this is the question that we get asked the most, is what level of humidity should we use? As a testing laboratory, we've selected plus 55 degrees C with 50% relative humidity. The reason for selecting plus 55 is a time factor, right? If you go down to 50, it's going to make your test longer. So we go plus 55, that's the most popular condition that we offer for accelerated aging. And we're going to add 50% relative humidity. Again, that's a lot of moisture, but that's what we're going to offer. Some of our other clients are considering other levels, like 20% humidity. Even at 20%, that's still a lot of moisture. That would be right over here. Okay, 40%. Again, off the top of the chart. So once we get the test results back, it's going to be up to you to evaluate your device to make sure that it's going to stay in a stable condition. Stable condition, again, acceptance criteria. Could that be tension? Could that be torsion? Could that be adhesives that have a negative, that moisture has a negative effect or impact on? So those are the things that we need to identify, and also the materials themselves. And the standard says rely on your vendor for the materials that you're using in your product. But not all of your vendors are going to have all the data you need based on the moisture sensitivity of the product. So we're going to have to negotiate between those. We can't just, it's not going to be a black and white type of thing. There's a very nice article that was written, and it's on our resource page on our website, a link to it, and they identify materials that are used, commonly used, in medical devices that you can refer to develop your test plan for your accelerated aging and determine what kind of moisture levels or humidity levels you might need. And of course, after the aging, we would do the normal sterile barrier tests, sterile integrity tests. So that would be, sterile integrity would be your bubble gross leak or dye penetration. And then your strength tests, and that's your peel test or a burst test. And so those would follow after the aging, and then, of course, the real-time data would have to follow after that. So are there any questions about this portion? All right. So this is a little bit of our accreditation information. 17025 accredited laboratory, ISTA certified as well. And if you, yes. Okay. Okay. So the question was that in ISO there's a UV requirement. Is there a UV requirement in the F1980? The answer is no. There isn't a UV requirement in F1980. That would be a different standard, and we would look to that standard to identify that. There are different types of UV that we can use. One of them is a fluorescent tube, and then the other one is a xenon arc lamp in the center. Chances are it would probably be the former. It would be a fluorescent tube. Yes?
How can I determine what level of humidity I should use for my product or package?
What level of humidity should I be using for my product or my package is the question. So the first thing you brought up is the package. So to use the F1980, one of the things you should do is identify what you're looking at, the package or the product. If you're looking at the package, use your data that you already have for the packaging. For the product, that kind of ties in to perhaps next generation products. You may not have had a problem, or you may have historical data to show that your product is adequate, but now you're making some changes, you're adding some of these materials that may be sensitive to moisture. You're going to have to identify what that is, how much moisture. So there's going to have to be an engineering study conducted, quite honestly, to identify what failure modes there might be, and then you can move forward with that information. The risk here is that you have too much humidity, right? So maybe we're going the other way now. We have too much humidity driving into the product, and that creates more problems for us, and it's not realistic. So we're going to have to work with that. We will work with you as well to help you identify what humidity level you should use. We have a shared chamber that I was telling you about at plus 50 degrees C, plus 55 degrees C with 50% humidity. And then we can also customize a condition for you and give you a chamber with that information.
Does the humidity level affect the accelerated aging time?
Does the humidity level affect the accelerated aging time is the question, and no, it doesn't. So the Arrhenius equation only uses accelerated aging factor and the temperature of the accelerated aging temperature and the room temperature. It does not take into account any humidity levels. And if we actually go back to the Arrhenius equation, even doing our own research, we find that humidity was not used in the determination of this equation. Thank you very much. Appreciate your time. Come by the booth. You can come by the booth and see us, and we can talk there as well. Thank you.